Hi, welcome to Moksha Nagasri Maths Academy. In the last video, I told that standard 10th introduction to trigonometry. The last exercise, the last problem, it contains 10 problems. Okay, I told that up to 7 sums. Now today, in this video, I am going to explain that 8th, 9th and 10th. Okay, be carefully watch. You should understand that what I am saying. See, problem number 8. What is that solution? We will see that. Okay, children. What is given? Sin A plus cosec A whole square, sin A plus cosec A whole square plus cos A plus sec A whole square, cos A plus sec A whole square, it is equal to, what it is equal? 7 plus tan square A plus cot square A. Okay, 7 plus tan square A plus cot square A, right? Okay, this is the problem. Okay, children, see this. Sin A plus cosec A whole square plus cos A plus sec A whole square equal to 7 plus tan square A plus cot square A. That we have to prove. See now, take this LHS, children. Take this LHS. What is LHS here? What is LHS? Sin A plus cosec A whole square, right? Plus cos A plus sec A whole square. Cos A plus sec A whole square. So we should expand both the terms by using the algebraic identity, one of the algebraic identity, A plus B whole square. Actually, you know that A plus B whole square equal to what, children? A plus B whole square equal to A square, okay, plus 2AB, actually standard form, plus B square. We can write A square plus B square plus 2AB also. Nothing will happen. Okay, na? Actually, this is the formula, algebraic identity to expansion of both the terms, right? Now, first expand this first bracket. So this one compare with this. In the what is the A place? Sin A. In the B place is cosec A. Expand according to this. A square. A square means what will become? Sin square A plus 2AB. 2AB means 2 sin A cosec A plus B square. B square means cosec square A. Right? Plus this also can expand. So in this place A is cos A and B is sec A square. A square means what, children? Cos square A plus 2AB means 2 cos A sec A, right? 2 cos A, 2 cos A sec A plus B square. What is B square? It is equal to 6 square A. See, children, actually we need, according to RHS, 7 plus tan square A plus cot square A. So when you are expanding this all, that when you are simplifying this all, you have to get the result in terms of tan and cot and also constant. Okay. So first, if you must focus on this tan square A and cot square A. Before that, see, children, you know that algebraic identities, that means trigonometrical identities, sin square A plus cos square A equal to what? 1. Okay. Next, reciprocal property. Trigonometrical reciprocal property what? Sin A into cosec A equal to how much? 1. This place becomes 1. Next one, cos A into sec A. Cos A into sec A. Cos and sec are both are reciprocal to each other. No? So that result is also equal to 1. So then remaining what are there? Cosec square A and sec square A. That has to expand. We have to take the trigonometrical identity. What identity is possible? We will see that. For all the problem, what are the notations? We will see once. Sin square A plus cos square A equal to 1. Sin square A plus cos square A equal to 1. Okay, next one, cosec square A equal to, be careful children, cosec square A equal to 1 plus cot square A, means cosec square theta minus cot square theta equal to 1. Now from that, cosec square A equal to 1 plus cot square A, because here angle is A now, that's why we are taking that A. Next, sec square A, so sec square A equal to 1 plus tan square A. Sec square A equal to 1 plus tan square A. Not only this, still what are there? Sin A into cosec A equal to how much? 1. Next, cos A into sec A equal to 1. Okay, that formula is also applicable. Sin A into cosec A, these are the reciprocal properties. Sin A into cosec A equal to 1. Cos A into sec A equal to 1. Okay children, so that be careful, remember these all identities, right? Now you see where we are eliminating that. In the place of sin square A plus cos square A equal to how much children? 1. Okay, plus sin A into cosec A. Sin A into cosec A equal to how much? 1 now. So 2 into 1 it is equal to 2, plus cosec square A. Cosec square A equal to how much? 1 plus cot square A. 1 plus cot square A plus 2 cos A into sec A. Cos A into sec A. Cos A and sec A equal to how much? 1 now. That means 2 into 1, 2. Right? Plus sec square A. Sec square A equal to what? 1 plus tan square A. Right? 1 plus tan square A. Now just you can simplify children. First we need constant. No? Just you see 1 plus 2, 3. 3 plus 1, 4. 4 plus 2, 6. 6 plus 1, 7. Okay, 7 plus tan square A plus cot square A. Tan square A plus cot square A. Of course, we can write first cot square A, then tan square A. No problem at all. According to given question, RHS is 7 plus tan square A plus cot square A. That one you got here. 7 plus tan square A plus cot square A. So, which is equal to RHS. Hence, LHS is equal to RHS. Okay, children, be carefully. In this problem, to get RHS, okay, you have to use these all the algebraic identities. The next problem I will explain to you. Question number 9. What is the question number 9? You see the solution. Question number 9. What is given? Cosec A minus sin A. See, be carefully. Cosec A minus sin A into sec A minus cos A. Sec A minus cos A. It is equal to what? 1 by tan A plus cot A. Equal to 1 by tan A plus cot A. Right. See, now take this LHS. Cosec A minus sin A into sec A minus cos A. It is equal to 1 by tan A plus cot A. Actually, according to the given textbook, they are given that hint given. Actually, in board examination and other exams also, they may give, they may not give us. Most probably they won't give. You has to understand what to do. First, you will see that LHS. Okay, children. If you take LHS, then it is possible RHS or not. Just you can see. First, LHS take it. What is LHS, children? Cosec A minus sin A into sec A minus cos A. Right. So you know that cosec is the reciprocal of sine. That means cosec A equal to what? 1 by sine A. And also sec is the reciprocal of cos. So that cos A is equal to 1 by sine. Cos sec A is equal to 1 by cos A. Right. So that in cosec A place you can write 1 by sine A. Okay children. In cos A place you can write 1. In a sec A place you have to write that 1 by cos A. So that according to these relations, see the given problem can be written as in the cosec A plus you have to write that 1 by sin A, right? 1 by sin A minus this sin you can keep it up. If you change both means problem won't be solved. Okay? Into ck. Ck means 1 by cos A. 1 by cos A minus how much here there? Cos A. Just simplify. You know that simplification, no? Okay? So we have to take that here one. Sin A is the LCM, right? Sin A is the LCM means sin A and 1 LCM is sin A only. Just we have to do the cross multiplication. 1 into 1, 1 minus sin A into sin A, sin square A. This cross multiplication is possible only when there is no common factor in the denominators. Okay, always not possible cross multiplication, you know that. And here if you think that 1 cos A and 1 LCM is cos A, then 1 minus cos A into cos A, cos square A. Simplify children. 1 minus sin square A and 1 minus cos square A. You should eliminate from the first identity. You know that the first identity is what? Sin square theta plus cos square theta equal to 1 now. Okay. From that cos square theta equal to what? 1 minus sin square theta. Sin square theta equal to 1 minus cos square theta. Right. So that from the first identity 1 minus sin square A place 1 minus sin square A equal to what I told you, cos square A by how much? Sin A. Your bracket means into children. 1 minus cos square A means sin square A. Sin square A by how much? Cos A. Now you should do cancellation. You know that cos A in cos square A how many times cancel? Cos A times. Just like x square by x. X in x square how many times? X times no. So that cos A in cos square A how many times? Cos A times. And sin A in sin square A how many times? Sin A times. What is the result now? Cos A sin A. Cos A sin A. But it is not equal to the RHS now. So that in this case you have to do that, must do in this RHS also simplification. Take that RHS. After doing RHS you will see that whether it is equal to LHS or not. Okay. Now what is RHS children? 1 by tan A plus cot A. Now we want in terms of cos and sin generally. That means you know that tan can be written as the ratio of sin and cos. Tan A is equal to sin A by cos A. And cot A means cos A by sin A. So it has to replace both. So that 1 by in tan A place you have to write that sin A by what? Cos A, right? Plus in cot A plus what? Cos A by sin A. Tan reciprocal no? Cos A by sin A. Tan is sin A by cos A means that reciprocal what? Cot no. So that means cos A by sin A. Cot A can be written as cos A by sin A. Simply you can keep bracket. If you keep bracket, no confusion at all. See now this bracket only has to simplify. This numerator as usual will be. Okay. There is no change in the numerator. See children. Only denominator bracket you are simplifying. What is LCM? Cos A sin A. Right? Cos A sin A. Now both LCM is taking no, both are multiplication you are taking no, so that directly do the cross multiplication. Sin A into sin A, sin square A plus cos A into cos A, cos square A. Okay, now you know that according to the first identity, sin square theta plus cos square theta equal to 1 now. That means sin square A plus cos square A equal to how much? 1. So that 1 by 1 by cos A sin A. So that can be written as 1 by 1 by sin cos A sin A. Cos A sin A. So that this is the complex fraction, you know that. Complex fraction is reciprocal. Cos A sin A goes to numerator. Yeah, already numerator 1 is there. 1 into cos A sin A, cos A sin A. See now, if you observe that LHS is cos A sin A and RHS is also cos A sin A. Hence, we can say that LHS is equal to RHS. That's it, children. This problem. Okay, be carefully. Here I use only cosec and sec. Okay, and also use trigonometrical identity. Then problem will be solved. Okay, be carefully, children. Now we'll go to the next problem. 10th problem. See, children, 10th problem, the last problem in that Roman. What is given? 1 plus tan square A by 1 plus cot square A equal to 1 minus tan A by 1 minus cot A whole square. It is equal to tan square A. Right? See the 10th problem. 10th solution. Write that 1 plus tan square A 1 plus tan square A by 1 plus cot square A, it is equal to 1 minus tan A by 1 minus cot A whole square. It is equal to, what is given? Tan square A. See now how to prove. It is equal to tan square A. See, children, that means in this problem we have to show that this part equal to tan square A and this part is also equal to tan square A, just like a transitive relation, you know that. A equal to B, B equal to C means A equal to C. Means according in this case both you have to prove, these two you have to prove that it is equal to tan square A. So that take one of the part. Okay, simply think that this is the first part, this is the second part. Okay, children, take now first part. What is given? What is the first part? 1 plus tan square A by 1 plus cot square A. We need tan, no? So that only cot we has to change. Cot is the reciprocal of tan. Cot A equal 1 by tan A, no? So that this can be written as 1 plus tan square A by 1 plus, in cot square A plus, what it has to take? 1 by tan square A. Right? So that this we can simplify. Right? So before I told no, before some by taking LCM. So what is LCM? 1 and tan square A? Tan square A is the LCM. This numerator we can keep it up as it is. 1 plus tan square A by tan square A is the LCM, no? Then remaining what will become? 1 into tan square A plus 1 into 1, 1. This is denominator, no? So it is the complex fraction. So that reciprocal has to do. So after this step I am writing now, children. 1 plus tan square A into this reciprocal I told now, what will become tan square A by tan square A plus 1. It is also equal to 1 plus tan square A. No problem. 1 plus tan square A. Why it is no problem? Commutative property, no. A plus B equal to B plus A. 2 plus 3 equal to 5. 3 plus 2 equal to 5 only. No? So now here account in this case, just is simply keep like this bracket. You can cancel this. What is the result now? Tan square A. So it is equal to 1 of the part. Okay, this result. Same, take the second part. 1 minus tan A by 1 minus cot A whole square. So same thing, cot A can be written as 1 by tan A. Okay, numerator keep it up. 1 minus tan A by what will become 1 minus cot A means how to write? 1 by tan A. Right? Again same like this LCM. 1 minus whole square is there children, that is very important. Whole square. It is equal to 1 minus tan A by, here what is LCM? Tan A LCM, no. So that whenever taking the tan A LCM, what will become 1 into tan A? Tan A minus 1 into 1, 1. Okay, actually this bracket is also not compulsory. Okay. See now this is whole square. Okay. First you write the reciprocal of this. Okay. How to write now? 1 minus tan A 1 minus tan A into what will become tan A by tan A minus 1. Tan A by tan A minus 1. Okay children, tan A minus 1 you can write from tan A minus 1 if we takes minus as a common factor. So how to write now? Minus of 1 minus tan A. Okay, whole square. See, be carefully children. From tan A minus 1, if you take that minus as a common factor, what is the remaining? 1 minus tan A. Just you can check it. Minus into 1, minus 1. Minus into minus tan A plus tan A. Right? So why you wrote like this means, see here if you observe the numerator, here 1 minus tan A. Here also 1 minus tan A. For cancellation, you can take like this. Okay. Now what is there? Tan A by minus. Tan A by minus means minus tan A. You know that plus by minus means minus. Minus tan A. Minus tan A whole square. Square is there. Square is minus becomes plus. Because of minus and minus plus. So it is equal to tan square A. But see now first part is tan square A. Second part is also tan square A. Totally both the parts are equal to what? Tan square A. Hence we can say that first part equal to second part equal to tan square A. Hence proved. Okay children, be carefully, you should practice more. This Roman particularly 10 sums are there. Okay, every problem is golden sum. Okay, according to that concepts, definitely they will give also 1 or 2 problems, definitely 100%, because of most of the algebraic identities and trigonometric identities are applicable in this exercise in this Roman. So be alert and be careful, practice well. Okay.